Hello students, so here is the suggested solution for assignment 3.1. So let's begin, right? So here's the question. This is a question on a quadratic graph. You're supposed to actually practice drawing a quadratic graph here. Table is given, function is given. The function is y equals to half x squared plus 3x minus 2. Okay, and the table is here. Now in the table, you recognize that there's some unknowns here, a, b, and c. So the first part of the question asks you to find the values of a, b, and c. How we do that, right? So how we read this table is that is this for each column. When x is equals to negative 7, y is 1.5. So how do we actually get these values? You see, I take x equals to negative 7. If I put it into or substitute it into our function, y equals to half, then change the x to negative 7. In a bracket, when you put a negative number, it saves you a lot of pain. So when you substitute in a negative number, encapsulate it in a nice little bracket. Okay, so plus 3 then times negative 7 minus 2, you should get 1.5. Okay, so it is a matter of substituting it carefully. So you substitute x equals to negative 7, y is 1.5. You substitute x equals to negative 5, you will get a value, and that value will be equals to a. You repeat the process for x equals to negative 3 to get b. You repeat the process for 1 to get c. So these two values, negative 7, 1.5 and negative 1, negative 4.5, is for you to test that you have pressed your calculator correctly. Okay, so I don't foresee that any of you have any issue with this part. It's just a matter of using the calculator carefully. So the solution, A should be a negative 4.5, B is negative 6.5, and C is 1.5. So once you have this, we can proceed to try to plot our graph, right? So the first thing you need to do is to check your scale, right? So the question actually provides the scale for you. It tells you that every 2 centimeter represent 1 unit. So you look at your graph, you can see that every 2 centimeter I make an interval and say this is 1. 2 centimeter later I say this is 2. And then the same for the other direction, and then to the right and to the left. Okay, so check that the scale and the intervals are okay. And of course, one of the most important thing at this stage of your graph plotting is to make sure that your range is okay, right? The leftmost value and the rightmost value should be in range. The bottommost value and the topmost value should be in range. So check that your axis is placed in the correct position, so that every point that you're supposed to plot can be found on the graph paper, right? If you position your axis in the wrong place, you may have points that you run out of space on the graph paper. So if that's the situation, you will probably have to redraw your graph, and we don't want to waste that kind of time. So just double check that your axis is okay, the interval is okay, the range is okay before we begin plotting. Okay, so of course don't forget to label, right? Label all the interval that you mark out, label the origin, label your axis x and y with the arrowhead there. Okay, after that, the next stage is to plot the points from the table with little x, right? Why we use x? Because well, actually x is the most accurate, right? As you give a crosshair, you know that that's the exact point. Because when the whole point of trying to draw on a graph paper is we want to try to be as accurate as possible. Of course, being human and we are not computers, so sometimes when we draw graph, some points may be off by a little bit. Okay, but the margin of error should not be too large. Okay, we try to be as accurate as possible. So how to have increased accuracy? Sometimes that's why I chose this example, because sometimes when we do this, we realize we only have 5 points, and if you want to draw a nice curve with only 5 points, it is often not enough, right? So we need more points. So how to get more points? Well, all the other points where the x value is not given, you can actually just repeat the process and substitute it into the function. For example, down here when x is negative 7, I have a point here, right? But when x is negative 6, I don't have a point on this area here, right? When x is negative 6. So what I can do is I substitute x equals to negative 6 into my original function, y equals to half x squared plus 3x minus 2, and get that value. Once I get that value, I can plot another point, right? But of course, when you plot the other point, you may not want to use x, because you don't want it to be confused with your the so-called official points that's given by the question. So you can actually just use a dot. That will help, right? So this is what we call the in-between points. In-between points that's given by the question, you can actually add them in. So we have here when x is negative 4, also there's a point missing. Fill it up on your own, right? and also for x is -2 when x is 0, etc. So you can use dots for those so that you don't clutter up your graph paper full of x's, but the original points that is from your table should be marked out with an x. Alright. Then of course you join all the points together to get a nice smooth curve, right? So if you want to be even more accurate with your graph, okay, you are actually allowed to create even more in between points. For example, earlier we have x equals to -6. This point here, you see, I put a dot there. We don't have this. We create this point. So what happens is, if you want to have even more accuracy, you can let x be -5.5 and get this point. So you can get a lot of points, as many points as time permit. And the more points you have, the more accurate your curve is going to be. So if you have sufficient time, you should try to get as many points as possible and get the most accurate graph that you can. Okay, so that's our graph. We have finished successfully drawing the graph. Don't forget to label, right? It's a good habit to always label everything. So after we draw the graph, label it, just write the equation of the curve next to the curve. Okay, and once we do that, we can proceed to answer the questions that is in the question itself. So the question actually first of all asks us to write down the coordinates of the turning point. So let's identify the turning point. The turning point will be right here, right at the bottom of the entire quadratic graph. So this point here is -3, comma -6.5. So write it down, turning point. This is the turning point, the coordinate. So the question asks for the coordinate, we give the coordinate, and this is how we write down the coordinate as ordered pairs. Okay, answer to the question, right? And then they also ask for the coordinates of the points where the graph intersect the x-axis. So the graph intersect the x-axis, we can actually look at the roots or the x-intercept, which is -6.6 as well as 0.6. But we don't want to give the answer as just -6.6 and 0.6 because the question asks for the coordinates. So give it in coordinates, right? So coordinates, we write it in this way, ordered pair, have a bracket and then a pair of numbers inside. So here -6.6, 0 and 0.6, 0. So these are the x-intercept. Okay, so we do that. Now the last part of this question, they say draw the graph of y equals to -4 and find the values, right? So y equals to -4, just draw the line. It's over here, right? It's a horizontal line. Again, after we draw the line, don't forget to label. So I label it y equals to -4 here. And what we are looking for is the intersection point between this line and this curve. So it will be right here and right here. So at the intersection point, what we can do is pull out our ruler and draw dotted line, guide it all the way to the x-axis and read off the value over there, right? So when we use the dotted line, read the value. This is -5.2, and on the other intersection point we got -0.7. Okay, so that will be our solution. Now to double check our solution, what we can do is actually we can take this x value and substitute it back into our original function, right? So for example, x equals to -0.7. If I put it back into this function, y equals to half x squared plus 3x minus 2, I should get -4, or at least a number that is very near -4. Why sometimes not exactly -4? Because sometimes rounding off happen, right? Your answer may not be exactly -0.7. It is -0.7 after rounding off. But it should be accurate enough, right? So you can actually use this technique to double check, to confirm that your points are actually correct. If your points are off, then you know you made a mistake somewhere. Look through again, pull out your eraser. You may need to adjust your graph or something. Okay. Right. The next question we have over here. Now this is not a quadratic graph. Okay, but there is a purpose why this question is put here, because I just want to highlight the important point that when we plot this graph, these curves, we must try to get a nice smooth curve, because over here you will find that the points seems to be a bit jumpy. So if we treat the drawing of a graph as though joining the dots together, you will get a very ugly looking shape for this particular example. So by throwing this example here, I hope to cultivate the awareness in my students that you should try to get a nice smooth curve whenever possible. Okay. Another point is that when I look at all the values of the y over here, the highest value is 3.5. Does it mean that the maximum value, the turning point, is at 3.5? Not necessarily so, Now for quadratic, we know that it's symmetrical. So if for quadratic, the value on the left and the value on the right of the maximum point is the same, then we know that that's going to be the maximum point, the turning point. Okay, or if it's the other way around, right, the left and right is the same but they are larger than the middle point, then that's the minimum point. For quadratic, that works because quadratic is symmetrical. Okay, but when it's not symmetrical like this particular graph, you cannot assume that 3.5 is going to be the maximum point. Now sometimes for quadratic, you don't even get that pattern, right? You will get, you know, two points could be the same value instead of one larger than the other, one largest or one smallest in the whole table, because sometimes the maximum point or the minimum point, the turning point, may not be one of the so-called official points that's given in the table. So we got to be aware of that as well. Okay, so let's take a look. So same thing, using the points from the table, I want to begin plotting, but before we do that, let's make sure that our axis is okay, our scale is okay. So based on the information that's given by the question, we check that the scales are okay, the interval okay, the range of the axes are okay, right? Then after that, label the interval, label the origin, label the axis. Once we have that in place, we can begin plotting. But one more thing, right? Because this particular question has context, that means the x and y values actually have units. So if they have units, you can include them in your labeling of the axis. Okay? Right, so we plot it with the points with the tiny x's, so it looks like this. So you can see the position of the x, right? So it's quite clear already that if all we do is just to join the dots together, this portion here will look very weird. Okay, see where my cursor is. This portion here will look very weird. Yeah, so instead, try to draw a nice smooth curve as much as you can. And when I draw a nice smooth curve, you can see my maximum point is actually neither of the two plotted points. Okay, so this sort of thing can happen. You need to be aware of that. Okay, so when I do this, then I can answer the question. When x is 5.5, what is the temperature? That means what is the value of y? So I just need to look for 5.5 on the graph. Okay, use a ruler, dotted line, try to find the position here. So 5.5 go up to the graph, then check the y value. It is about 2.8 degrees Celsius. Okay, use dotted line to help you to identify this point. Show it, okay, show it on your graph paper. Right, the next one, the difference between the highest and the lowest temperature. So this question here is to force you to make sure you can identify the maximum and minimum point, right? So the maximum point here, I identified to be about 3.6. Minimum point is about negative 2.1. So the interval, the difference, 3.6 minus negative 2.1, 5.7 over here. Same thing, use dotted lines to guide you to make sure that you get the right position. Okay, so the use of dotted line on graph paper is very critical and very useful. Okay, and for part 3, they ask how long in hours and minutes the temperature was above 2 degrees Celsius. 2 degrees Celsius, what do? We mark out draw the line y equals to 2, right? So draw the line y equals to 2. Then again look at the intersection point, right? The intersection point, use ruler and identify the values. So down here, when it first hit 2 degrees Celsius, is at 5 hours. And then when it get out of 2 degrees Celsius here, it is 8.2 hours. So the difference, right? The difference is 8.2 minus 5, which gives us 3.2. And if we write it in hours and minutes, it should be 3 hours and 12 minutes. Okay, and that is how we can actually do this type of question. Right? I hope you are successful. Have a nice day.